Hello, everyone, and welcome back to Code with the Italians. We have been just showing you some recorded stuff, but we're back live today and with a guest. What a guest we have today. I'm so excited. We have Leland with us from Google. You probably have heard of Leland if you've ever heard about Compose. So we are super excited because today, not just we're back doing live, even though we still have our last slice recorded episode this Sunday. We're going to have our friend Mario from Amazon. We're going to be talking about Android in the TV space. But then after that, from next Wednesday onwards, we are back with our regular programming. We're going to be doing live coding. We have a bunch of very exciting guests lined up as well. So yes, there's been a lot of activity recently preparing for the next few streams. And today, I'm just talking too much, Ivan. You just do.
No, we are live. We are also with a friend from Google. And we have a recording for next Sunday with a friend from Amazon. We have a lot of friends. But jokes aside, I'm super excited to have Leland today. There is a lot of stuff that we want to know about Compose, things that are actually we are doing, but they are working, but we want to know if actually we are doing it properly or we are holding it wrong and we are just lucky that things work. So I'm super excited because what we do usually is look at the source code, look at the documentation, but probably, I mean, if you talk to the people that actually build the thing, it's easier. It's easier. So we are very lucky. Leland, welcome and thank you for being with us today. How are you doing?
Yeah, I'm good. Thanks for having me. This is great. I don't have to worry about any of like the actual streaming part. I just get to, talk and get questions asked. This is the easy way to stream.
Before we start,
Awesome.
I just want to thank Warden of North for subbing. Thank you very much. And hi, everyone in the chat, including people that are asking, Leland, when are you back on Twitch yourself?
Yeah, I mean, so maybe I'll just say something real quick, but I haven't streamed in a while. I'm bummed that that's the case. Life has just sort of gotten a hold of me and things have been pretty crazy. I would like to start back up again soon. I've got family visiting like tomorrow, so this will become a guest bedroom probably after we get off the call here. But I'm gonna stream at least 1 or 2 episodes soon, maybe in the next week or two. Hopefully.
We will be, I think I put your channel in the auto host list. So if you go live, people can follow you from our channel as well. So good. Shall we get started? The topic today is a fairly big one. So for those that have been following us before, we're going to be asking Leland some of the questions that we have been asking ourselves in the past, but really didn't have an answer for. And for those that are new today, what we have been doing in the past, 25 episodes, we have been
that was
working on a digital well-being app that is called Bundle, that is written with Jetpack Compose, obviously, and we have some questions. Like, we've had a lot of guests. Each one has helped us doing something or other thing. And today we have someone that is going to help us at a higher level, not just like, how do we add, I don't know, data store like we did with Florina. It's like, how do we fix our code? How do we make it better? So
yeah, well, I tried looking through the code. I didn't get to look through everything, but I did kind of do a brief run through of the code base, and I'll start off by saying I think things look pretty good. So it's a nice clean code base. I like it.
Oh, I don't mind the variables names and the functions. So there are reasons behind that.
Yeah, people can use the channel points to make us name things, and that's the result.
Yeah, which is an awesome idea, by the way. I watched a few episodes, and yeah, I love that.
Feel free to steal it if you want.
Nice. Thanks.
So we actually have a bunch of questions that we had prepared. And one of them, let me check my notes. No, wrong screen. Okay. So, okay. The first question is a very philosophical one, which is, so we know that to make sure that that a composable stays pure and idempotent, you want to hoist state outside of it and just pass it in. But my question is, there is a point at which you need to stop, right? And this is I guess a bigger question in the realm of state management in Compose. Like, how do you organize the state? How do you avoid having to pass too much state and moving? Like, where do you decide where a state is at the level it should live in and not bubble it further up?
Yeah, I mean, I think that there's some guiding principles, but I don't like to think of anything as like a dogmatic rule, that you have to follow to a T. But I mean, generally speaking, one of the things I tell people is like, okay, well, like, lift the state up to the point where it needs to be sort of owned and managed, and it makes sense for it to be owned and managed there. Like, if you've got whether or not like an accordion is expanded or not, that state doesn't belong in your, top level like app navigation state or something like that. It's somewhere lower down. But then there's some other things about like, okay, well, is the data, like the main data for this screen, loaded or not? And that should be sort of at like the screen level, and so there's different levels for different state. And I think like if you want a sort of quick and fast rule, is like lift it or it should be as low as it can be while still being properly owned. So like the lowest point where all of the points where that state is red sort of come together, and that's like, that works a lot of the time. But then there are some weird cases, right? So like sometimes you've got state that like just maybe the design of your app is like there's some notification thing up here in the top corner and then some other thing down in the bottom left, and it's reading the same state. And well, if you followed that rule, then maybe that would mean that it's like top level app state or something like that, which it doesn't necessarily have to be. So it's not a hard rule, but it's I think the state should sort of belong where it's semantically owned, if that makes sense.
So it's kind of, you can think of it in a similar way as you do with scoping of variables in code, like normal variables. You put them as high as they can be, but also as low as they can be, because you don't want to overexpose states, right?
Yeah, I think there's this tendency for people to start, like, when they start playing with Compose, they think, you know, all of their intuition that they've had for, you know, their entire career is gone, but it's like, it's not the case. Like, you know, just kind of like standard rules apply here. Like, I think if you're building a class, you know, and you have some, you know, some properties, like, they should sort of naturally belong together. And oftentimes, you know, you say, okay, well, here's, you know, here's this state about, you know, I'm struggling to think of a good example, but, you know, I mean, the things that clearly don't belong together, well, it might make sense for that state not to be like held in the same component then. And so that should be like sort of a natural smell where you say, oh, okay, for some reason, the way I wrote this code, like, these states are getting grouped together, but this one doesn't quite fit. Maybe that's an indication that that one belongs somewhere else or something like that.
Mm-hmm.
You know, I think that the intuition that you already have is probably not leading you too far astray.
I think that's actually a very good point, which is like, to some people, many people, including ourselves, Compose is still a relatively new thing, and we're still like trying to figure out what the patterns are, what the approach that we need to have. And every now and then I find myself thinking, oh, how do I do this? How do I make this work? Like, how do I clean up this code? And then I realize it's code. It's Kotlin code. I know how to make this look nice. I just don't think of it, because to me, my mind is still partly in the XML versus Kotlin state of things. So I need to get used to it a bit more.
Yeah, and that's a lot of the beauty, is that, you know, by really embracing Kotlin or a language, you know, that people already program in, it's like that number of things that we don't have to teach people as part of Compose. It's something they're learning as part of Kotlin and programming, and it's things they already know. And so, you know, think of a composable, you know, a composable function isn't exactly the same as any other function, but you know, it still has all the same properties, and you know, you should think about refactoring and things like that. All of those skills that you had, they all still apply.
And this is something that actually we discussed with Anna Chiara, Sebastian, if you remember. You know, we were actually appreciating the fact that there is a lot of stuff new that you need to learn, but then you also have a lot of knowledge that you already have, right? I mean, you're using a language that you already know, and patterns like MVI, that they became somehow a bit more like popular in the idea of a state, you know, the idea of events, passing a lambda here and getting a stream there. You know, that's something that we got familiar in the last couple of years, and they fit nicely with the whole Compose mindset. Plus, there is a lot less boilerplate for recycle views, so I love it.
Was it you clipping your reaction on the first episode when we were doing the lazy list? You lost your shit.
They actually pointed out on a comment on YouTube that there is a very specific point in the first episode where I actually snapped when I realized that the whole recycle view thing, it just became like 3 lines with a LazyColumn, and I just lost it because, you know, it was a period that I was building adapters over adapters and multi-type recycle view. Everything is a recycle view. I was building so much XML, and then Sebastian was like, Ivan, let me show how you do a scrolling list with Compose. And yeah, it was a nice moment where it was also a very painful moment for me. It was actually, it was incredible.
Yeah,
So
lazy list is one of those things where, like, whenever I'm creating slides, it's like it's so nice to have something that, you know, the code just fits nicely on a slide, and you're like, oh,
Is
this
the
is so
same as
much better.
the Java versus Kotlin examples that you know back in the
we
day.
have a question. Just checking the chat. We have a question about performance, recycle view versus LazyColumn. I'm personally not aware of performance differences of the two components. Do you have any more insights about this?
Yeah, I mean, so, you know, lazy list does, like, the two are very similar, but there are still a few things that like recycler view can be set up to do a bit better. Like one of the, you know, lazy lists, we are trying to remove a lot of the boilerplate, but still sort of make everything possible. It's still sort of early on in sort of like the where lazy list will end up, and that there are some more sort of APIs that we're working on. Like one thing that I'm aware of is, like, right now, you know, so lazy list will recycle items in a sense, like in a compose sense, which, you know, makes it very similar to recycler view, where, you know, it won't recreate the layout nodes and stuff like that. But we kind of only have at the moment like one item type. And so if you have different item types in a recycler view, so you have like a heterogeneous list, and you're getting a lot of benefit out of like reusing the same item type when a new item enters into the window, then, you know, you might see some degradation with lazy list, because right now we just sort of assume one item type. We're working on that and working on like the right APIs to sort of expose that, because that's an important use case. But, you know, there are like things like that where it's, you know, we're still kind of figuring some things out. We've also, you know, just kind of like recycler views is a great piece of code. And there's a lot of the sort of scheduling that recycler view does that, you know, it took some time for us to kind of fit that into the compose model in the right way. And there are some ways that we think in the future we'll be able to you know, even get better than recycle view at some of the scheduling, mostly due to the nature of how we might be able to do composition in a background thread and things like that. So still sort of a lot more improvements to be made to lazy list, but, you know, in the what we've seen is in the cases where it's not like a heavily heterogeneous list, we're basically kind of neck and neck, like on par with recycler view and in the performance there.
I think there was a follow-up, which was for one type of item in the list, the performance then is equal, right? Which is pretty much.
Yeah. Yeah, I think that's fair to say. It's always hard to compare these two things together, but you know, that was sort of like the kind of primary target for lazy list was to you know, to be equivalent, at least in that regard.
A non-performance question that was coming a bit earlier that we missed earlier from Mark is Compose bundling its own version of Skia, or does it depend on the system version of Skia? And I would add to that, what are the gotchas there? Is there anything that we need to be worried about in terms of SDK or things that might degrade if run on versions that are not hardware accelerated for some stuff, for example?
Yeah, it's a good question. So we don't bundle Skia. We use the platform version of Skia, which you know, does mean there are some cases where we do some things that that are kind of polyfilling the behavior of future platforms. Like I think one of the cases is like shadows and stuff like that. Something to think about. I know there's probably like half a dozen cases, but I don't know them all off the top of my head. And you know, I mean, I'm sure, you know, other things will come up in the future as as the platform Skia keeps improving and we, there are new features and, new hotness that comes out that Compose will obviously want to take advantage of. And so, the sort of standard stuff we'll have to figure out what approach we want to take. Do we want to try and recreate it in a less performant way on older platforms, or do we just want to sort of gracefully degrade into something that's equivalent but not the same, stuff like that.
Got it. Was there any other question? No, I don't think so. Okay, so I think I'll go on to a question from our code base, actually. Oh, wait. Okay, there's another question from the chat. Maybe I'll give priority to that one, even though I don't know if you can answer it, which is, what is the vision from Google for what concerns Compose multi-platform?
What's the vision?
Yeah, that's the question.
Yeah, I mean, I think Kotlin multi-platform is really cool. It's one of the things that initially drew me to the language, was the idea that this sort of behavior of like expect actual is kind of built in. I think we're still kind of figuring that out. Like JetBrains, is working on Compose for desktop and Compose web, which is really cool. And we kind of designed Compose from the get-go as sort of this reactive engine, declarative engine that we really thought of. I've thought of it as a language feature, sort of first and foremost, and something that could eventually be thought of as this part of the language and not necessarily specific to any sort of platform or even to UI. And then Compose UI was built on top of that, and that's now what we all think of it as Compose. And we tried to kind of keep that sort of sense of layering and all of the abstractions that we put into Compose UI, are sort of thoughtfully built to kind of be as platform agnostic as possible. And so in that sense, that was a lot of the vision, was that these things could be leveraged in this way, and we're already seeing it like with JetBrains and stuff like that. But yeah, I mean so the vision's there, right? But I don't know. I think everyone wants us to say like, oh, Google's going to do this or that. It's like Google is focused on Android, but but we're building this thing so that other people can kind of leverage it in pretty cool ways.
Nice.
And we're already seeing that, and that's really exciting to me.
Yeah, I for one, I'm super excited I can use Compose on desktop, and I will never stop thanking my colleagues for that.
Yes, that's true. I have a question in the chat that I would like to address, because I don't know how to answer that. There is somebody, Pete Doyle, that is asking how to keep using like one data class as a view state, UI state, without unnecessary recomposition. We're risking recomposition. This is one of those things that I have as questions also from our own list. The whole recomposition thing, and how the remember thing that I don't know. I mean, I just throw remember every now and then there, and I hope it works. So I would really like to have like an explanation. But recomposition is a big topic, and with Sebastiano, we have been doing a lot of guessing. Well, not a lot, but there was a fair amount of guessing.
Yeah.
Is this gonna be recompose or not? And I'm not confident. I don't have like a confident answer. Like, oh yeah, I can write this thing, and I'm 100% sure that it's not gonna recompose.
Yeah.
any help.
And I
No, that. Go ahead.
yeah, sorry, just wanted to say I'm gonna share the screen because we actually have one specific place in the code of the app where I have a comment. Is like, do we need to remember this or not? I don't know.
Yeah, who knows? Oh, and apparently somebody knows, right? So
Yeah.
lucky for us, we can ask them.
So
Yeah.
here we go.
Okay. Well, so you
No
bring
context.
Up,
just
bring up a really good point,
without even
right?
context.
Well, so let's leave the code example aside because I want to address the first thing. Which is like, Ivan is like saying,
Tu sei un pazzo, va via da qui.
Yeah, we
what's
have sound.
the background sound going?
Yeah, sorry, it's Mark is being annoying.
Mark is just buying sounds. So
Got it. Yeah. Well, I was just confused which data source it was coming from, or like was that coming from Skype or what?
No, it's Twitch.
But anyway, so you bring up really good point, Ivan, where it's like, okay, given a line right in my code, with what confidence can I say this is going to recompose given this situation or not? And I'm not proud of this fact, but very few people in the world can really sort of answer that with confidence. And then that's not.
Is it a good thing or a bad thing?
No, that is a bad thing. I'm saying that begrudgingly, right? Like I don't want like that sort of, it's like that feeling of like magic and the black box and stuff like that. Like that's not what we strive for. We don't strive for like the system to be, so complex or something that people don't understand it. But so here's the thing is I think that a lot of people can have a rough mental model of kind of roughly what's going to recompose and what won't. And that's I think very sort of easy to have. But that mental model isn't actually going to be right 100% of the time, because there are so many sort of micro optimizations that the compiler ends up executing that can lead to surprising sort of answers to that question. But the important thing is that it shouldn't affect the actual behavior of the app. Like essentially the compiler is trying to minimize the amount that gets recomposed while still ensuring that everything that would have changed gets updated. And because the compiler is really trying to kind of whittle that down to the smallest subset of the hierarchy, sometimes the compiler is smart enough to really fool your mental model into thinking, oh, well, this is going to get recomposed because there's no way it couldn't, right? But then there actually is, and there's some way that this gets skipped or gets hoisted there or something. And so it's created this situation where it is hard to end. Like once people kind of figure out like, oh, this isn't recomposing, but I have no idea why. It makes me both sad and happy at the same time, because it's like, oh, okay, like our compiler is being smart enough that it didn't need to recompose here, and so it's not. But then at the same time, it's like, oh, I've created this sort of confusing moment for this person, and so that's something that I kind of struggle with all the time. But I think the mental model that you should have is, basically, if you have a piece of state that got read somewhere, right? So mutable state of, wherever you read that, the sort of the easy mental model I have is like, go up to the nearest composable function, and that's what'll get recomposed. The reality is a bit more complicated than that. But I think if you have that mental model, then that's like, it doesn't matter if the reality doesn't match that. That's sort of like the right way to think about it.
So to give an example here, I have this pager state that is a remember pager state. So if this state changes, what gets recomposed is the column scope, right?
Actually, no.
Okay.
But only because column is an inline function.
Oh, okay.
And so so inline functions, like there isn't actually like a body to sort of recompose. So surface is not inline, so it'll actually be the surface that gets recomposed.
So it's the
and it's not actually the surface; it's the composable lambda that you pass into the surface.
Yeah, this argument of the surface here.
Right.
Okay. And just to kind of tie up to this, like the reason I didn't know if I need to remember this explicitly is this is a data class of which every single value property is remembered individually or comes from a parameter. So do I still need to wrap this pagers, the onboarding pager state into a remember mutable state of, or is it okay to not do it? It works, so I know it fine. It's at least in practice it works, but I don't know if it's wrong.
Yeah. So it's not right or wrong. Both work as you point out. I can kind of point out the differences that will happen. And so basically, whenever this gets recomposed, you're going to create a new onboarding pager state instance. Now, onboarding pager state is data class. So it's got an equals implementation that compares each property. And so the new onboarding pager state and the old onboarding pager state, they're going to compare equals to each other. And so because of that, when you pass it into onboarding pager, it'll compare it with the old version and it'll compare equals. And so onboarding pager will get skipped. And so if none of the values changed, which as you pointed out, like they're all being sort of, remembered somewhere else. So they won't change. And so as a result, onboarding pager will get skipped. So the sort of trade-off in your mind, well, I don't know if this should be in your mind or not, but so the trade-off in my mind is, if you remembered it, right, that is, if you tried to remember the creation of this thing, sort of to be correct, you would want to remember it with all 5 of these properties, like which all 5 of those can technically change. Their inputs coming from somewhere else. So you would end up remembering the creation of it, but in order to remember with like those 5 keys, you'd have to compare all 5 keys in order to determine if you needed to create the new instance. And so at that point, you're already then comparing these 5 properties just to save the comparisons that are going to happen here when equals is called. And so the only thing that you end up really saving is the allocation of this object, which we can debate whether or not that's worth saving or not. Realistically, it probably depends on how often you expect this, to recompose, right? So like if you had an animation happening here, then the allocation of this object, for every frame might be concerning, right? But if this is just, if this is recomposing once, whenever like some concrete state changes, like, some Booleans flipped, or maybe it's never even being recomposing, then this is nothing to worry about. And in fact, this is probably the more efficient version because, remember like that's with remembering that with these 5 keys, it's gonna, that'll take up 5 slots in the slot table. And like, there's other machinery that'll end up happening, as a result of that. So it's like, it's not super cheap actually. And so I think the code you wrote is just fine.
Okay. By pure chance, it was a 50-50 50-50 chance that I wrote it right for some definition of right. So I can take out this comment. That makes me happy.
Now we know.
Now we know.
But so an important part of me saying that, so it is like, I guess a critical part here was that onboarding pager state was a data class.
Yeah.
If it wasn't, then onboarding pager, every time this surface recomposed, then onboarding pager would also recompose, which also may not be the end of the world, right? Like that might be fine. But that is like I would have to click into onboarding pager to see like, okay, well, how expensive is that or something.
So as a sloppy rule of thumb, if it's a data class that takes in a bunch of things that are either remembered or coming in as parameters, and you're not on a particularly hot recomposition path, it's okay not to use remember. But if you're not using a data class, then it's bound to potentially create problems because equals is not implemented, or unless equals is implemented. I know it's a very, very sloppy rule of thumb, as I said, but seems like there's no easy answer, yes or no.
Yeah. I mean, if it wasn't a data class, like again, it's sort of not the end of the world, like, because, I think what you want to think about is like, okay, composition is this giant tree, right? There's this like hierarchy of composables, all over the place. And your composables, like the ones that you write in your app, they're kind of like just the top part, right? Like once the onboarding pager is going to call some other composables, and like eventually you're going to end up like referring to some compose library built composable like button or text or something like that. And then those things are going to have composables as part of their implementation. It's sort of composables all the way down until you end up with like layout nodes, basically, which is private API to compose anyway. But at some point the expectation is like when you're recomposing, like if those values didn't change, so like let's say you've got a bunch of text on a screen, and you're just flipping one of the texts is like changing values. When you recompose that screen, it's not like re-executing the entire hierarchy, because like all of those individual texts, like those are going to skip, and so those end up a lot cheaper than on recomposition as they did on composition. And so I guess like what I want to create is like these things are real, they matter, right? Like like understanding, okay, like equals is implemented, so so this will or won't happen or whatever. But I don't want you to think that if it doesn't happen, if you forget to write equals or whatever, that like all of a sudden you're toast, because it just goes one level deeper, and then you end up decomposing that state into individual values and passing those values somewhere else, and it's like it's going to skip somewhere else, and so because of that, it's incrementally more expensive. But your intuition for like, oh, if I don't do this, then I'm screwed, like that's not necessarily the case.
Okay, so essentially it kind of needs to be the perfect storm for it to be a real problem, right? A number of factors that go in, such as, again, being in a particularly heavy recomposition or a frequent recomposition. And before we go to chat questions, because I've noticed there's a bunch of them, I have one last small clarification that I would like to ask you, Leland, which is, in terms of recomposition and relayout, like what is the difference? What is the cost difference between the two? Because I've heard some explanation, like some high level explanation on the Android developers backstage, but I'm not sure I understood it correctly, because I'm still thinking in terms of the view, where you do measure, layout, and draw.
Yeah, that's a great question. So basically, the way I think about the system is sort of like 3 or maybe 4 phases if you want to include the platform's render phase. But basically, you've got composition, you've got layout, and then you've got draw. And then draw ends up creating essentially display lists, which then get sent to the render thread, and then that ends up as pixels on screen. But so if you think of those 3 phases as sort of like the compose phases, composition happens, and that's when these composable functions are executed. And what that does is that essentially creates a list of changes to apply to layout nodes, which is sort of like Compose's view equivalents, right? These are like this is the tree that Compose is building. And so those changes are then applied to layout nodes. And then when that happens, there's basically a very similar kind of invalidation phase to like what views currently have today, which is where if anything sort of affecting layout has changed, or really it gets invalidated, then there's sort of like a relayout pass. And then when that happens, if anything related to drawing gets invalidated in any of the previous two phases, then there's a redraw that happens. And so as a result, you can kind of think of it as like like tiers. Like if you like just redrawing is sort of the best, right? That's going to result in the least amount of work. Above that is you can do a relayout and redraw, and then that's sort of like the second most optimal. And then there's recomposition, relayout, and redraw, and that's sort of like the third. Technically, it's possible to recompose and not have any sort of relayouts and stuff like that, but generally speaking, you're recomposing because something changed, and if something changed, then you're going to end up reflecting it on screen somewhere, and so something's going to get invalidated. And there's actually there are certain things that have been built, certain APIs that have been built to sort of allow you to more easily only affect one versus the other. So like these phases, all like everything that recomposes is like technically not true, but basically like when you mutate a state object, that's when a recomposition gets scheduled, right? And that happens because when you read the state object, it sort of subscribes to the nearest composable scope. Our layout and draw phases are architected the same way. So if you read a mutable state value, it doesn't have to be, if you read a state value in layout or draw, then it sort of subscribes itself to that scope in layout or draw. And so one of the sort of like performance tricks or like performance like minded sort of things that you can do is you can try and move certain, if there's a state value that is read and it's only really affecting layout, then there might be a way for you to move that read into the layout pass instead of in the composition pass. And what that then buys you is that when that value changes, no recomposition happens, only relayout happens. And then similarly, you can move something into draw if it only affect, like, so if you're changing the color of something, right? Or, the opacity of something, or, whatever. Or like a really common one in animation is like, maybe you're changing the position of something, but it's just a translation, right? So like you're actually not wanting to affect layout. And so, you can do it with like an affine matrix transformation. And so that's something that could be moved completely into the draw phase. And so if you do that, then and you're sort of doing that in a tight loop, then that's going to be much more efficient.
Got it.
If that makes sense.
Got it. Yeah. Thank you very much. Ivan, do you want to find some questions in the chat?
Yeah, actually, I don't want to take too much time for our questions, but I don't want to take off the table the performance part, because I'm gonna go to the chat now because we have a couple of interesting. So this is, so I'm reading it like I know what I'm reading, but that's not the case. Okay, so somebody is asking, I don't want to butcher your name, so please bear with me. I'm just gonna only read the question. Can you ask if any of the produced state or derived state of makes sense here? I'm never sure when to use those. That makes two of us, my friend, because so if it's still on point, the question if it's still on point.
Yeah, so let me just talk about derived state for a second. So derived state, if you're not familiar with it, because a lot of people aren't, there's an API called derived state of, which allows you to pass in a lambda, and that lambda will return a value. Well, actually, maybe I can
Sure.
write some code here on
Let me
screen.
switch back
I don't
to the
know
screen.
Yeah.
Off you go.
Okay, so like one thing I can do here is I can say sum equals derived state of, and then I can pass it a lambda, and I can say sum state that value plus other state. Let's see if this imports here.
Should work. If not, I'll do it.
Yeah, it's not doing it for me,
Okay.
but not super important. This sort of gives you an idea of like the structure of this API, right? And so basically, this is a lambda that does a calculation, and it can be arbitrary code that gets executed. But the idea is that like during that execution, some state values might get read. And the return type of sum here, so like let's say, so this ends up being, something that's like, let's just say both of these are ints or something, right? So then the sum now is a state of an int. So you can call .value on it somewhere else in your code, and that will create a state read just like reading normal state would. And there are some slight differences in this because like basically wherever I read sum.value, right? So here I can just say sum.value. Now calling sum.value is essentially equivalent to calling this lambda at that place, except for a few important things, right? So this creates a subscription on this state value, but that state value is sort of dependent on these other values. And so what happens is whenever one of these values changes, whenever one of the dependencies changes, just this lambda gets invoked. And if the result changes, only then will this like composable then get reinvoked. And so it sort of creates like this sort of mini recompose scope, if you want to think of it that way, where it will do a recalculation, and if the result didn't change, then like you're good. And so like a common case where this is like really valuable is let's say we've got like scroll offset mod or actually like what's the way we want to calculate this? So like, divided by, item width or something. Like let's say we're doing something like this, or item height, right? And so what this might represent is like, nearest item index or something. And you can imagine that scroll offset is a state value which is changing very rapidly as you're scrolling through the page. But this isn't changing very rapidly. And so you don't want the two to sort of have the same frequency of invalidations. And so using derived state of would sort of give you that. And then there's some interesting other ways that you can utilize it. Like we're using it in the navigation graph API, I believe, to allow for you to create your navigation graph as like a function of snapshot state values, and have it sort of recreate the navigation graph when those things change, but not sort of recompose your whole screen if something changes, but like the resulting graph is the same or something like that. So anyways, that's sort of like derived state of, and that's when it can be useful. The thing that you want to be, I guess, like careful about is like the first example I showed. You know, some state that value plus other state that value. Like this isn't really giving you much, because anytime one of these changes, the result is probably also going to change. And so then, you know, you didn't really change the behavior of anything. So like, you know, you kind of want to think of it as like a tool for when you've got something that's changing at a very high velocity, and there's some derived state that ought to be changing at a lower velocity. And so you want to create that sort of mismatch.
Okay, yeah, because here, for it to be possible that the nearest, well, that the derived state doesn't change, you would have to have the both states change in different directions by the same value, which might be unlikely, right?
Seems unlikely.
Yeah.
Yeah.
Got it.
I honestly forgot if I just answered the person's question or not. I don't. I just started talking about derived state. Did that answer the question?
Seems like it. Seems
Okay.
like it. They're asking if derived state of would not make sense in the onboarding pager state, as it would recompose on the exact same frequency. So I guess putting it, here.
Well, for onboarding pager state, like I don't actually know where these things are coming from, but it looks like most of them are.
They're passed in,
Okay, I guess
all
you
of
got the-
them apart for the pager state, I think.
Like it, if these are valid, like you're not actually reading any state values here. You're only passing state instances and creating some object from it. And so derived state of probably wouldn't do anything here, right? Like where the state values get read is probably, you know, inside of onboarding pager.
Yeah.
Where they're calling the properties of onboarding pager
So
state.
it could be useful at a lower level if, for example, there was something that was reading the offset from the pager state and maybe something else and wanted to check if a specific condition was met.
Yeah. And also, I think you know, there's a decent, if you search for usages of derived state of in the code base, I mean, you might see really good examples of where this ends up being practical. And like I think the scroll offset example is one. It's sort of like the canonical case that I think of, where you know, you're calculating some visible item index or something like that based on a highly animating value like scroll position. And there are some other places we use it too, but that's probably the best way to learn about like the right ways to use it.
I'm going to, Ivan, do you have another question ready, or otherwise I'm gonna just pick one?
From the chat, something, well, once again, something that I don't know anything about. Annotations. We have annotations table. I mean, I have been doing this, like, I mean, we do it twice a week since April. I don't know anything of this stuff. This is how the level of our audience, you know, we are learning here. I'm definitely learning. So stable at immutable annotations, how they affect recomposition? I mean, what are they talking about?
So
is it a thing? I mean, do we have?
It makes me happy that you don't actually know.
I just know at composable and at preview. Those are the two annotations that I know. I don't know what. I mean, at stable and at immutable, what are the typical use cases?
Yeah. So for those who don't know, let me just sort of explain briefly like what they are.
Thank you, Lee.
But
I like how he goes very, very generic, you know, for those of you that don't know. I mean, more like, even get your shit together, for fuck's sake. It's more like, I like, so let's go with the polite way. For those that don't know about at stable and at immutable annotations, please.
No, I mean, so It makes me happy actually that you don't know what they are, because I want people to be able to use Compose frequently and often without ever knowing these things, because I it's my goal to make it so that they're not needed at all, and that that people don't think about this, and that the compiler is just sort of smart enough to figure it out. But anyway, so let me explain kind of what's going on. So I've kind of alluded to the fact that composable functions can skip. Like we talked about how onboarding pager, if it determines that the input parameter to onboarding pager is the same as the previous value, then it'll skip. There's a couple of things that like need to be true in order for that to happen. And so, one of the things sort of goes back to like the word Seb mentioned earlier, which is idempotence. But like, let's not get into those types of terms. So let's just say, in order for us to sort of safely skip a composable function, the sort of underlying assumption that we're making is that if the values that you passed to it didn't change, then there's no need for us to call it again, right? Now that works really well if your functions are like mathematical, right? Like you've got some function of inputs, and then you do something and you spit out a result. But a lot of functions in that you end up writing in code don't behave this way, because you do sort of this like sideways data loading, right? Like, so you reference something that's in like the global scope or whatever, and maybe it's a value that gets mutated over time, and so then every time you call it, it ends up actually producing a different result, because it's using this like global mutable state sort of thing. So there's a couple assumptions that Compose has to make, and then there's also a couple of sort of concessions that we have to make in order for us to like achieve some things. So one of the things that Compose sort of does is that we kind of ignore the global state case, right? So we sort of say, you're writing composable functions, like we want them to sort of behave in this sort of mathematical way that we're talking about. Like we want them to skip if the values haven't changed. And if you end up using this global state in a way where once you, and when I say state here, I don't mean like compose mutable state or like snapshot state, because that's different. So just like some mutable value in the global scope. If you reference that, then like Compose doesn't know that you reference it. Like it doesn't attempt to detect whether or not that's like a mutable value or not. And so if you expect it to recompose and incorporate the new mutable value over time, it won't by default, right? Like so the sort of mental model that users should have is like, if there's some value that's changing and you want Compose to sort of recognize it, use Compose mutable state. Like those are the things that Compose will sort of know about. But then there's another category of mutable things that sort of do make sense for Compose to think about, which is when you pass a value in. So if I can have a class with like a mutable property, right? And it's just a normal Kotlin class, like let's call it a count wrapper or something, and it just holds an integer and it's mutable, and we change it. If I mutate that value and I pass it into a function, a composable function, I kind of expect it to, like, when I call it again, it should actually get called. It should not skip. Like, skipping is a new behavior that composable functions have that, like, it doesn't match our intuition as programmers. Like, if I write a call to a function, I expect it to execute. And so
it makes sense. It makes sense.
But like a lot of people ask us, is like, well, why don't you just assume that every object is immutable, and it's like, shame on you for not using immutable objects and stuff like that. And it's like, well, you'll end up hating Compose really quickly. Like if we like basically it's amazing how quickly you're just like, why is that function not executing? I called it, like,
Yeah.
you know, like why,
Yeah,
you know,
yeah.
and so then it just gets weird. So
Yeah,
we,
just start chasing ghosts. You don't want to do that.
it defies all expectations. So basically what we do is we skip the execution of a function when we know it's safe, you know, with the exception of that global state case that I talked about. And so part of it being safe is basically we understand that the values that you're passing into it are things that that like aren't changing over time. And so immutable is just an annotation that allows us to say this class is immutable. So like it's an object that Compose can safely sort of assume if it registers as dot equals with the previous value, that it's the same. And so it's not going to be if all of the parameters sort of match that, then there's no need for us to call this function. Stable is very similar, except it's a little bit more flexible in its contract. It's sort of like none of the values will have changed, or if they did change, then we told Compose about it, right? Like we sort of we've told Compose that this value has changed, and so you know you don't have to worry about it. So you can sort of in all regards sort of treat it the same way as immutable in terms of how it happens. And so basically for a function to skip, all of its arguments need to be stable. And immutable is like a superset of stable. So that's what the annotations are for you to mark things like that. However, the Compose compiler will infer certain types as stable. And so you don't necessarily need to go marking all of your types as stable in order to like get these benefits. So like the Compose compiler, and this was one of the projects that I streamed a lot of the work on in the compiler to do this inference. But so the Compose compiler will sort of detect if an object is mutable or not, and if it's not, then it'll kind of mark it in a way that the Compose compiler will be able to see. And so the hope is that you can rely on this inference and not think about it as much. But there are certain cases where you might actually have an object that is mutable, but it still has all of the properties that like Compose needs in order for it to be safe to treat as like one of these parameters that it can compare with the previous one. And so in those cases, it might make sense to annotate the class as stable. And so like one case where this comes up is like if you have a serialization library or something that is creating all of these like classes that are just deserialized from a JSON stream or something like that. Sometimes those generated classes like they're technically mutable, like in terms of how the Compose compiler sees them, but you never use them in Compose as like things that you can mutate the values on. And so like that's like a good use case for classes that you might want to mark this way, and stuff like that. And there's definitely still work to be done here to make this better, but also make it a little more configurable in terms of like what classes you want to treat in this way, and like you might be able to pass some arguments to the compiler to make it do this. But right now, it's sort of just the inference that we do, sort of best effort, and then the annotations.
Cool.
Okay, thanks.
I have been asked a couple of things in the chat, so I am going to relay those. The first one is, Leland, I think you have been involved with it to some level. I don't know what level, but do you know if at least some of this information is in Jorge Castillo's book about Compose internals? Maybe you can expand a bit on that, because someone in the chat was asking if you recommend it. I don't know, because I know you've been working with Jose on that, at least proofreading, right?
Yeah, so Jorge asked me to review the chapter about the compiler. And so I did, and yeah, it's great. I mean, I gave a lot of feedback as to, sort of very minute details as to, to make sure that everything was accurate. But, overall, Jorge's put a ton of work into that book, and so definitely can recommend it. And, everything that I've seen in the compiler section is accurate, at least, as of 2 weeks ago, right? Which both of these things are changing, so always consider that. But yeah, I think it's definitely worth picking up if you're wanting to learn more about the internals.
Yeah, I bought it, and it's going to be the next book I read, and after that I think it's going to be Chet's book about Android origin story.
True story.
Yeah.
Same here.
There was another question which was about the pros and cons of composition locals. I guess it's more about like if there's any heads up about using them for any particular consideration.
Yeah, so composition locals, for those who don't know what they are, is like it's basically a value. You can think of it as like one of the potential terms we were going to call these was like tree scoped locals. And so you can, like, one of the values that we provide a Compose UI that you get is called local density. And so you can basically, in your code, you can write like essentially anywhere in a composable function, you can say local density dot current. And what that'll do is that'll return to you the density sort of at that position in the hierarchy, which, for density is mostly going to be the same throughout the whole hierarchy. But you can imagine, if you have multiple screens with different densities, that may not always be true. And so composition locals are useful for values that are sort of intrinsic to like that part of the tree. Like there's some value where it might be different at another part of the tree. But it's also something that you don't want to pass around to every single composable, because like you maybe often don't want it or need it. Like our themes work in this way. So like you can imagine, you might want to implement a feature where like, you've got your theme, but then like maybe you've got like a theme preview composable or something somewhere else where you're previewing a different theme. And so then that you're scoping a different theme to just part of the hierarchy. Or you can imagine that like there are some composables that don't sort of want to, you don't want every composable to sort of take in a theme as one of its parameters, because you might just want that theme to just sort of be like a known thing. And then you've got composables that read from the theme, but don't know or don't like sort of require that you pass it in directly. So that's sort of the idea behind composition locals. However, like the problem with them, so to speak, is that it's like an implicit dependency. So if you've got a composable that reads from the theme, well, that means that it depends on the theme, but it's not one of the inputs of that function. And so that can be problematic if like the users of that, the consumers of that composable, sort of don't know about that dependency, but sort of need to. And so the things that you want to be careful about are creating these implicit dependencies that really should have been explicit dependencies, because you really need the consumer to make the decision of like what that value should be. So that's kind of like a red flag. And like, so one of the kind of rules of thumb that I use is that composition locals ideally fall into one of these two categories. So one is it's a value that has a very sensible default, right? So like there's a default value that is sort of often the one that you want. And then when you define the composition local, you can provide that default value. And what that means is that it's an implicit dependency, but it's one that won't blow up in your face. So anyone can use this composable anywhere, and it won't throw like a runtime exception, because these dependencies aren't tracked by the type system. So like it's it's not going to be a compile time error if it's not provided. It'll be a runtime error. And so ideally, always provide default values for composition locals. And then the other category is like things that don't have a default value, but basically should never not be provided. Like they're essentially always going to be there. And so like one example of this might be like the ones that we provide as framework authors. So like local context, local density, local locale, and like stuff like that, where essentially there's always going to be a value for one of those things. And you shouldn't really ever be able to get into a situation where those things aren't provided. And so that way you avoid these sort of like runtime, this like implicit typing dependency sort of thing that composition locals create, and you can avoid runtime exceptions. So yeah, that would be like my sort of rule of thumb.
And Afzal was asking a follow-up to that, which is it okay for composition locals to hold something like a function?
Sure. Yeah, I mean they can hold anything, whatever makes sense for your use
I think
case.
what they mean is that a good idea?
Yeah, I mean, functions can be used for all kinds of things. So I guess it depends, but in general, it doesn't sound like a smell or something like that to me. Like I think that seems reasonable.
Okay.
I mean, in 3 months, I'm gonna find people doing like network calls and database reading with inside this. Well, I mean, he said that I can use a function, so.
Well, I mean that that's like one of the things
everybody's gonna clip this 10 seconds where you're saying, "Oh, that's okay." But he said that. Well, no. We have decent audience, so that's not gonna happen. Cool. I'm loving this. Are you having fun?
Yeah, I don't know if you're
Okay.
but I'm having fun.
Yeah. I think I found another question. Well, actually 2 questions. I'm going to ask one first, and then the second one is something that we also wanted to talk about. So I'm going to go after that. But the first one, if the chat stops scrolling, is that if you have any personal opinions on on a fitting architecture for an app that uses Compose. They're saying that they are becoming a fan of MVI, for example.
I guess like, not strong feelings. Like I think we all have, at least I have a way, like if I was writing an app, there are certain things that I would do in terms of the architecture, but I think generally the MVI architecture works pretty well with Compose and sort of the way it's structured. And I think you want something where the sort of like buzzword term, I guess, is like one-way data flow. But you've got sort of state management systems where you kind of have a piece of state that is sort of like accurate for the current amount of time, and you can kind of just like flow that down your UI however it makes sense to you. And then when there are changes to that state, like that's done in a very controlled way. So like you kind of go back up to the roots and in whatever way that sort of system kind of lets you do that, and you say, okay, I'm mutating this thing, now let's kind of start over. And that's kind of the approach that Compose takes in general. Is like the mental model that we often tell people. It's like pretend Compose is just like rebuilding your entire UI from scratch every time something changes. Obviously, that's not actually what it's doing, but that can be like a reasonable mental model.
No. I don't know if you're looking at the chat.
I knew this will fire back. Oh,
okay. No.
So, I mean, that's a lot of points. How can you come up with that amount of points? Okay.
So we can't say that word for the next 5 minutes, but we can say banana instead.
So what happens
Yes.
if we do?
Nothing.
Well, we just shame on us.
Okay.
So yeah, you know what? So I want to take the opportunity. Jetpack banana, yes. Well, actually, it's kind of catchy though. So just to like easy up a bit the moment, I want to thank everybody that are supporting the stream, because we managed to achieve our first goal from building a community point of view. Because yesterday, well, a couple of days ago, we got the first payment from Twitch, and we invested the money to actually buy stickers. So we are waiting for delivery. It's gonna be about probably last week of August, and we are basically getting a bunch of pizza code with Italian pizza stickers that we are starting to give away. The way we want to no, we are not buying bitcoins. So the the idea is that we are gonna try this bot that you saw in the chat. It's called Nightbot, and Nightbot is able to run giveaways. So in the next few minutes, the bot is gonna watch the chat, and everybody that writes the word pizza, just lowercase, just pizza, in the chat only once. Everybody can actually just write pizza, send a message with pizza, and they are going to be eligible for the giveaway. And then the bot is going to pick the word. It's gonna pick like the winner, and the winner, then we are gonna just send a message, and oh, that nice, and it's
Spam incoming.
we are gonna just well, we're just gonna send the stickers. So this is the first step that we promised you, that we want to give back to the community. The way we are able to give back is fair enough. The way that we are actually able to do this is through subscriptions, and subscriptions can be free for you if you have an Amazon Prime subscription. So basically, Uncle Jeff, while he's very busy trying to go to space, is actually also giving you the opportunity to subscribe to a Twitch channel for free every month if you have an Amazon Prime subscription. So there is a link that I every now and then send to the chat. If you have an Amazon Prime subscription, please just check the link. Oh, thank you.
We have a
Thank
sub.
you
Thank you.
for the subscription. That's great. Basically, you just need to connect your Twitch account with your Amazon gaming account, and then when you land on our Twitch channel page, you will see that the subscribe button has a new button that is called subscribe with Prime for free. And we get a couple of dollars out of that. But with those dollars, we actually buy the swag, and we pay for the stamps to send you the stamp. So that's the idea. You basically, with a subscription, you're basically buying a stamp, kind of. You can participate in the raffle. And thank you, Mark. You are very, very generous. If you don't have an Amazon subscription, you can still buy a subscription like with normal money, no Bitcoin or no Ethereum kind of thing. But you can actually subscribe to the YouTube channel. and like the VODs on YouTube. That's also another source of analytics that we like a lot. And with this infinite rant, we are out of the 5 minutes, so we are good to go.
You were speaking very slowly.
Thank you.
Very, very slowly.
Yeah, that was the first time ever. But let's try to understand if this thing works. So just I'll bear with me for another second, please. So if I roll it,
Aha, we have a winner.
So we have a winner.
So yeah,
Nice.
Ivan, you will get in touch with them, and
yes, absolutely.
yeah, well, we will keep doing this, well, without the word ban, hopefully, over the next live stream sessions as well. Shall we get back on track? Because we don't want to take too much time out of Leland's day. I would say
Yes.
Let's go with the last question, because I think there's also something that Leland wanted to talk about that is somewhat related to this. And for this, I'm going to share the screen again. Okay, so this morning, I have read this very interesting article by Will Scheller that was comparing some performance metrics in Compose for what concerns the first frame draw time. So essentially from when you start the application or the activity, how much time it takes for Compose to draw the first frame on screen. And I saw there was some conversation about this between you, Leland, and someone else on Twitter. I think the big outcome from this, that to me was kind of expected, but maybe it's unexpected to others, is that just rendering XML views on screen, on the first time you load something, it's going to take less time than if you use Compose, even by itself or mixed in with XML or recycler views. Maybe you can give some context to this and explain a bit what's going on.
Yeah, well, so a few things. One, like I happened upon this article as well, and I think whenever I see an article that's like talking about Compose performance, I sort of never know what I'm going to get on the other side. But this article was actually very well written, and responsibly done. Like I'm very happy with that. It had, there's sort of like a list of like 5 things. It's like, well, you have to make sure that you do this, and they sort of did all of them, except for one, which is sort of expected. So this is a great article. You should check it out. It's a good read. There's some the conclusion here I think is pretty interesting, because this is sort of like a known thing, which is that the reason for this gap here, right, in sort of like the we'll call it like the properly compiled Jetpack Compose case and the pure XML case is the time to sort of first paint or initial content or whatever you want to call it. Sometimes Compose can end up looking quite slow here, and this graph I think is actually the important one to look at. And so this is where you see that this is especially slow the first time, right? And so this is like the same screen loading like 4 different times, I think. And the first time it loads, it's like much slower than the other 3. And so the data that they're putting in the graphs here is the average case, I believe. It's either the average case or the first case. I'm not sure, but a lot of people might look at this and just sort of be confused, like, well, why is it different? It's the same code, executing each time. And so to understand that, I think it's important to understand like what's actually happening on your device. And a lot of people don't have intimate knowledge with this, and I didn't either when I first started investigating this. But so let's talk about sort of the different stages of compilation that your Android app goes through, right? So you're writing Kotlin code in your app, And so, you've got this .kt file. You throw that over to the Kotlin compiler. That's going to end up producing a set of class files. And those class files are in JVM bytecode. And that's sort of like the language of, the Java ecosystem and all of the, Java or Kotlin dependencies that you grab off of Maven, et cetera. Those are all in jars, which hold class files, and or AARs, which those hold class files as well. So all of those things come together, and then when you build your app and like deploy it to a device, you take all of those class files and then you essentially convert those, you compile them into Dalvik bytecode, which is the .dex format. And that's sort of the language of your device. So your device understands Dalvik bytecode. And so, there are different ways to go from class to Dalvik, but like R8 is one example, which we recommend. And so there's some important things that happen at this stage, which is where you have essentially your entire app. The compiler, R8 in this case, knows your entire app, and it's like the final app. And so because of that, it can do what are called like whole program optimizations. And this allows for you to sort of, eliminate dead code and perform some like inlining and stuff that you couldn't otherwise do without changing public APIs and things like that. And so there's a lot of optimizations that happen in this stage that benefit Compose a lot. And you can see that from some of the graphs in this article where with R8 and both enabled and disabled, there's a pretty big gap. So then you have Dalvik bytecode. And so these DEX files, this is what ends up getting put in your APK, and then that ends up getting installed on the device. And this is where the knowledge of a lot of developers ends. But we're not done yet. So we're now on device. And at this point, the Dalvik bytecode needs to get compiled into machine code that your device understands. And this is where Art comes in. Basically, Art has a compiler of itself, and this is like when you refer to JIT, just-in-time compilation. Art is the one doing that sort of compilation in that bit, and this is where different devices behave differently. So, if you look at like Marshmallow and Lollipop, which I guess would be the two flavors that Compose ends up working on, those both have Art, but they also are platforms where Art would fully AOT compile the apps. So once the Dalvik bytecode ended up on your device, Art would immediately go and compile all of it, every single method, into machine code, and then it would run that. And this takes a lot of time. So this is like, if you remember the sort of optimizing your apps like dialogue that would show up when you updated Android or something, and it would take like, many minutes to be done. That's like Art going and compiling all of the apps on your phone. And so for Lollipop and Marshmallow, the whole app is AOT. So like, that has some nice benefits in the Compose case. The reason this matters is because everything in the framework is compiled, right? So like all of like everything in the platform, it's compiled to machine code, like, when it's installed on your device. And views are a part of that. So the entire UI toolkit that is like in the operating system, all of that is running the sort of most optimal machine code that it can be. And then your app is just sort of calling those methods. And so that's like a thin amount of sort of user space code calling a very thick amount of compiled framework code. With Compose, the distribution there changes quite a bit because basically we built an entire UI toolkit in user space, and that has a lot of advantages. It means that we can fix bugs, and you can upgrade on your own timeline, and you don't have to wait for OEMs and all that stuff. So there are a bunch of great benefits. But one of the big downsides is that means now that changes that distribution of you have this user space code, which isn't always compiled to machine code. Sometimes it's interpreted. And you have all of that code calling now essentially only Canvas APIs that are in the platform. And so there's a lot more code that needs to be JITted in your app when the app starts and when you call that first, when you sort of create the first kind of compose UI in your app. Now, that means that if the app wasn't fully like AOT compiled, all of that compose code, when it first runs, it's going to get run in Art interpreted mode, and then Art will compile it, and then the next time it gets run, it'll get run as machine code. Which Art in interpreted mode is very slow, and so like basically, kind of no matter how well we wrote Compose or something like that, if it's running in interpreted mode, it's not gonna be as fast as like framework views, right? So one of the things that we can do here, well, okay, so let me first explain what happens then on non-Lollipop and Marshmallow. So after Marshmallow, we started doing profile guided optimizations in Art. And so what that means is that when you first run an app, it'll execute that code in interpreted mode, like the user space code. But then what happens is that Art is sort of keeping track of what methods it runs, and then it stores that information in a profile, and then in the background, Art then uses that profile to selectively compile the parts of the app that were run before. And so then the next time you run the app, those things are optimized on startup instead of running interpreted, and just everything that's left, that is then sort of JITted on demand, right? Which is what just-in-time compilation means. And so then that drastically improves the performance without causing really long delays for compilation, and also like using up a bunch of space on disk for these compiled methods. So that's how basically everything post Marshmallow works on Android. And what that means, practically speaking, is that if you use Compose, what you'll end up seeing, and I think the blog article does a pretty good job of showing it, is you'll see like the first launch of an app be in the slower regime, and then every time you launch it after that, it'll be faster. And even more so, like you'll see that like the first few seconds, maybe when you launch an app, some code will run slower, like animations and things like that. But then, after the JIT sort of settles down and acquiesces, like you'll see kind of things run pretty fast. And so this isn't great, right? This isn't like, I mean, it's great that things, end up faster in the end, but this is a pretty bad experience when you've got, like the first time a user loads your app, that's like your first experience with the app. And so, you want that to be a positive experience. You want it to be fast and all those things. And even worse, if you've got developers sort of understanding, performance, like, they're going to, launch the app once, measure the performance, and then go back and change something, push it up and then launch the app once. And so then they're like almost always going to see the bad case, right? So we sat down and kind of thought about how to improve this a bit. So one of the things that we are doing recently, you might have seen there's a new library that a new Jetpack library called Profile Installer. And this is a library that I wrote that you don't really have to use. Like Compose depends on it. You don't really even need to know that it exists. And it doesn't do that much. All it does is it basically allows for us to install what's called a baseline profile when your app starts up to get the Well, let me explain what a baseline profile is first. So that, I talked about how art creates this like set of, this kind of log of methods that ran. And it'll use that then to selectively compile different methods. So that's great. But like sometimes there are methods that we kind of know we always want to compile. And in Compose, there are a lot of them. And so essentially what we did is we've now created a way for people to define sort of the list of these methods and package it with their library on Maven inside of an AAR. And so we call them baseline profiles, but it allows you to define these method sets, which then whenever you compile your app will sort of all get merged together and will build a profile that will be shipped as part of your app. And then what happens is we can install that profile right away on device and selectively compile those methods so that whenever the app first gets launched, it'll sort of act as if all of those methods were compiled like they would be if they were part of the framework. And so this essentially removes this gap that we were this performance gap that we were talking about like almost entirely. And so this is like a really effective way for us to basically kind of level the playing field between user space code and framework code. And so this is really neat. We're going to be talking about this more as time goes on. This like kind of came in really hot, like as Compose was going 1.0. And we're still kind of making sure that everything works properly, but we've seen really good numbers kind of firsthand of this essentially eliminating the gap. The problem that still exists that we also want to fix is that like this doesn't quite solve the developer like going and measuring the performance like locally. And so then you end up with really responsible developers like we're seeing in this blog post who really want to understand the performance but maybe don't know these sort of nuanced details, and they end up measuring it and then they see a gap, which is pretty worrying. But with this sort of technology, like we end up removing a lot of that gap in production, and there are ways to measure this locally and sort of see what you'll end up with. And we'll be working on tooling to sort of make it sort of always the case, so that when you're like profiling the app in Android Studio or something, we'll make sure that these profiles are installed the proper way so that you take advantage of it. So anyway, so this is like kind of the big thing that ends up mattering for Compose, and this is like kind of what I would call like a global optimization. Like it doesn't change the way you write code or anything like that, but it ends up having a very pronounced effect to the actual perceived performance of your users in production, and especially in the sort of moments that matter, which is like and the time to first paint, kind of time to first interaction sort of benchmarks, as well as kind of helping out that first experience that people have, like new users have with your app. And so I don't know, that I think can kind of explain for those who are wondering like why we're seeing that sort of gap in the blog post. And so I just wanted to talk about that, I guess.
Yeah, thank you.
Did that all make sense? Did I lose you guys? I'm curious. Like I just droned on for like 10 minutes, but.
Well, actually, people are very excited in the chat. So
yeah, to me this is super exciting. Like I don't understand anything about compilers, but at an intuitive level, I understand what this means. It's kind of like a pre-digestion in a way of the code, so that you can get rid of hopefully all the performance gap that you have with Compose. And yeah, there's a lot of people asking things on the chat. Before we go on, Leland, are you in a hurry? Because there seems like there's a lot more questions, but I don't want to keep you on too long.
Yeah, no, I'm good.
Okay. Then let's get cracking. Okay, so the first question we had was something. Let me find. Okay, so Styrianoskaki is asking. At some point, I remember Leland talking about doing some tricks with the Play Store to help with Compose apps in regards to app size and maybe performance. Do you have any updates on that?
I might have been talking about what I just talked about.
Okay.
I'm not sure. I mean, this doesn't impact size at all. Well, I mean, I shouldn't say it doesn't positively impact size at all. Technically, we're adding a profile to the APK that you ship on devices, but the profile itself is very small. A few kilobytes, and that also, we're working on actually removing that because there's other infrastructure in some platforms where we can ship the profile separately, and it ends up kind of being we can remove it then from the APK. For like overall size of composing things, it depends on what you use. Like if you're using R8, it'll do its best to get rid of code that you're not using. So like, the amount of size that the Compose libraries take up in your APK is going to be different if you write a Hello World Compose app versus if you write a whole thing, because you're using more of the Compose toolkit at that point, and so R8 won't be able to get rid of as much. But the kind of examples I've seen is like the sort of cost, and ends up being around 200K, like if you're using Compose in a reasonable way, and that like includes stuff like Kotlin standard lib and coroutines and stuff like that, which end up as transitive dependencies. So if you're already sort of pulling those things into your app, the cost will be even less. Because I think coroutines ends up being like 70K or something like that. So it's like pretty chunky itself. But yeah.
Okay. The Apache 64 was asking if there is anything that we can do on our side to reduce the first launch delay, or if this would be enough.
Yeah, so maybe what they're asking is like how do we get rid of the delay locally so that we can see the performance that users will see, which there is a way to do that. Right now it involves like some ADB commands and stuff like that. I'm happy. I don't have it like right in front of me, but basically there's a broadcast receiver that you can call to have the profile installed, and then you can just run that before launching your app, and that'll work. But this shouldn't be needed for very long, right? Like we're working on making it so that this is just an option in Android Studio that you can say, install this profile after launch. An important thing to understand though is that this requires that your app is in release mode. Basically, if your app is in debug mode, everything is JITted no matter what you do. Art will just completely ignore everything you ask of it. So so this will never change debug mode. And also, if you're in debug mode, there's other things that Compose does that, like for tooling purposes, that is is going to have negative performance impacts that make it so that you can do a lot of things with tools, but if you're actually wanting to understand performance, you definitely want to look at a release build.
Yeah, that's actually a very good tip. Whenever you're measuring anything on Android, because we have seen over time, over the years, several times someone looking at performances and then saying, oh, these numbers make no sense, and then, oh wait, I'm looking at the debug version of the app. And I think, yeah, maybe with Compose it's even more, because there's additional stuff that is done in user land as opposed to what maybe views would do at the OS level, right?
Yep.
Oh, there's a question that I'm a bit afraid to ask. Even do you want to ask it? You can pretend you don't know what they're talking about. The one from Pete Doyle.
Let me see, because I was okay. Oh. I don't get it. Okay, for be possible to shadow compose this one.
Yep.
Okay, for an SDK, do you think it will technically be possible to shadow compose if you don't want downstream project to have to consume compose, or align versions? Was a random thought, not sure is a good idea. So somehow you want to just build your stuff in Compose and hide from your consumer?
Yeah, I guess sort of like some SDKs do for, I don't know, they might be packaging Guava, but they don't want to have Guava on the class path because it's going to break stuff for others.
Yeah, I guess this is like, I don't know, like Jar Jar does this type of thing.
Yeah, I guess.
I mean, this all sounds possible. You know, I don't know. I guess whether or not it's a reasonable thing to do for your use case is debatable. But yeah, it just depends. But I mean, it sounds possible. I don't know why it wouldn't be.
Okay.
Thanks.
Just checking if there's any question that I missed. Folks in the chat, if there was anything that we missed asking, now it's your time to ask. Otherwise, we are kind of done for today, I think. Before we go, I just wanted to very quickly point out something. So we were coding today and cooperating in Android Studio. I am super excited that we're finally able to do this because I promise this is not a sponsored thing. I'm just very excited as a user of the thing, even though it's from JetBrains. But we're using what's that code with me, which is a very nice thing. Essentially, allows you to use your IDE as if it were Google Docs, and the code stays on the host side. The client, the guests don't need to install anything. It does everything by itself, and it's great for pairing. And why am I bringing this up? Because in the future, now that it's actually available for Android Studio and we can start using it, yes, it requires Bumblebee. Given it will
Does it?
be, yeah,
I mean,
yeah.
if you want to host it.
Yeah,
okay,
for the host.
Yesterday
yeah,
I was
for the host.
Okay, yeah.
And yeah, so it's very useful, and we're gonna have more interactivity with our guests. Like Leland today was able to just jot down some code. That's what we're aiming for. I'm super excited about it. It's still in preview for what concerns Android Studio. They sent me the link for the Android Studio EAP something. Because the installing is a bit different. I'll tweet the link later because obviously I forgot. I forgot it. So yeah, that's just wanted to point this out, and thanks to the Code With Me team because they helped me set things up earlier. So I guess lucky me working with them. But yeah. The other question, the only question that we got was if it's okay to use pineapple as a pizza topping. You do you, Kerry. You do you.
We are not judging you.
Yeah.
I mean, plus you are in Berlin, so I mean, it's so Berlin, so you can do whatever you want.
Yeah. You can have currywurst on your pizza if you want.
Wow, that sounds like a nightmare. Okay.
Okay. So that said, Oh yeah, sorry, last 3OI. I don't know what links you were trying to post. We have put anti-spam thing to try and avoid having people like bots joining the chat and asking if we want to be famous. So
Yeah. It happened, and the answer is no.
no. But yeah, with this, I would say thanks to Leland a lot for helping us understand Compose way better than we did before. Like
Your patience
I
with me.
I think I have learned it's something I say more and more as we have guests on the stream, but I think in the past 2 hours I've learned more than in the past 2 months about this specific topic, and it's great, and that's why we have people, and we're super happy to have people like you, Leland, and all of our guests that always teach us something. So thank you very much.
I had a ton of fun, so thank you guys for having me, and I just think it's really cool. Like I obviously, you all know I got into live streaming recently, and I just think it's a cool niche of the software engineering kind of community of just having people code live and stuff, and I think it's really cool. And so yeah, I thanks for having me on.
Yeah, we have you, and now soon in September we're also gonna have Adam McKay, which is another code live streamer, as a guest. I'm just announcing it. But yeah, I think it's super nice. And obviously, Leland, if you ever wanted to stream without the hassle of streaming, you're welcome back anytime.
Well, yeah. I mean, with Code With Me, you don't even need like a powerful machine. You can be on the couch and Sebastiano hosts everything. So you're just gonna be, oh, this thing runs so fast. Oh, on my, I don't know, like Arduino. You can actually enjoy your tablet. But jokes aside, it was a pleasure. Thank you for being with us. Thank you everybody in the chat. It was awesome. I actually very happy to announce that we smashed every possible Twitch record that we had. Amount of people in the chat, amount of people live at the same time, engagement, it was through the roof. Everybody was actually learning a lot. My dog is hitting me from behind the desk. That's nice. Spike, be nice. And I want to remember that the VOD is going to be available right after the stream on Twitch. So if you feel that you missed something, you can just check the VOD. Like the VOD on YouTube is going to be available in a couple of days as usual. If you happen to watch the VOD on YouTube, please like and subscribe to our YouTube channel. I mean, I'm doing the influencer bit now. Yeah, never gets old. I'm doing it for Mark. I mean, he enjoys this so much. But jokes aside, we love the engagement. Comment and subscribe on YouTube. Things are out for free for you to enjoy and to learn. And we are doing this for the lols.
I mean, we're definitely having fun. Last thing before we go, just another reminder, we have our last Slice episode this Sunday at the usual time, where we're going to have our friend Mario Viviani, which you've just heard saying, "It's a me, Mario." Is going to be with us talking about Android on TVs. And yeah, it's a recorded episode, but Ivan will be in the chat. I will be far away in the mountains, but Ivan will do flag duty.
Yes.
And yeah, on Wednesday, we have the next live episode, and the guest is going to be our very own VIP, Mark Bubbly Boopy Allison. And yeah, we'll see
honorary Italian.
We'll see you soon. Thank you again, everyone that has joined us, and thank you, Leland. Hope to see you soon again. Have a good one. Bye.
Ciao.